Hello students, good evening. Maithili, Aditi, Sanju, Vikashini. Okay. So today there is a specialty, and this is the last day of the year, and also this is the last session of the work energy power topic. Okay. So இதோட we'll be winding up the work energy power topic. அதுக்கப்புறம் we'll start the next chapter, which is the last chapter of the mechanics, the system of particles and rigid body motion. Okay va? So we are in the discussion about the collisions dana. So collisions lo we have covered which one? Head on நம்ம cover பண்ணிருக்கோம். So head on lo we talked about the head on perfectly elastic, அதுக்கப்புறம் head on the inelastic, and in head on the perfectly inelastic collision, which we also call as what? Plastic. Okay. So everybody, what is the way in which we differentiate them? By using the coefficient of restitution dana. So for the perfectly elastic, right, what do we have? E is equal to 1. Inelastic and sonna E is what? Between 0 to 1. Perfectly inelastic, that is what we call as plastic. Okay. So angana E oda value will be 0. E is what? The relative velocity of separation after the collision divided by the relative velocity of the approach before the collision. Okay. So already nama E patti we talked about one important factor, and mostly for the head on type of collisions the significance of E will be prominent. Okay. So air na, like the velocities, right, will be confined to one single line. Okay. And that is also the line along which the impulse force will be acting. So the impulse force is that collision force, right, that will be acting along that same line, whichever line the velocities are present on the line that act agum. So the coefficient of restitution, right, it is a good measure for the impact of the collision. Okay. Adanala the coefficient of restitution has more meaning in analyzing the head on type of collision. Okay. So even we are going to look at the oblique type of collision. So oblique and sonna, what is it? The velocities of the particles will be in different directions. Okay, say for example inga parunga, let us assume that this is coming like this, u1 vechukonga, it is coming like this, u2. They will be in different directions, general case. Okay. Collision kapram they may go in different directions. Inga parunga, maybe this is going a direction like this, adoda velocity v1, it is going in a direction like this, adoda velocity v2. Okay. Now when you have an oblique collision, inga enna theriyuma, the collision impact inga parunga, so this is the contact, right, this is the contact surface. This line is called as what? Tangential and sollu. So the contact surface irukku theriyuma, that line will be called as what? Tangential. Okay. Adukku perpendicularly if you draw a line, that is what we call as the normal line. So that is what we call as normal line. Okay. So oblique collision enna, this a normal line and tangential line will be important. And because the collision oda impact, right, will be only along that normal line. So in case of oblique collision, the collision oda impact, it will be along only the normal line. Okay. So the impulse forces or the collision forces, right, will be acting along this common normal direction, on the direction of the act of. If you are saying that the impulse forces are acting only in that direction, paranga, this is a very important thing. The components of velocities, okay, the components of velocities of particles along tangential direction, along the tangential direction will not change. Okay, that's very important. Yeah, because the impulse force are acting only in the normal line, right? Ipo parunga, for the object 1, other initial velocity enna u1, adu nama component pirichi we can just write it down, right? One component along the normal direction, ingonnu along the tangential. So tangential direction la irukra component of velocity change agadu. Enna in that direction, right, no impulse force are acting. And madri the second, so the first particle nama sonna, this is second particle. Second particle appadida, the velocity of the component which is along the tangential direction, right, adu change agadu. Okay va? So the velocities will be changing only in which line? The velocity components which are along the normal line only will be changing. Okay va? Because of the collision change enga varum, the velocity components which will be in the normal line anga da change varum. Okay, so even the coefficient of restitution, so head on epidi we are saying simply coefficient of restitution is velocity of separation after the collision divided by velocity of the approach before the collision, அப்படிதானா? But இங்க என்ன தெரியுமா, the coefficient of restitution is also defined along that normal line. So normal line சொல்றதுக்கு பதிலா we also sometimes call it as impact line னு சொல்லுவோம். Okay, so normal line is also called as what? Impact line. இங்க பாருங்க, so if you have the coefficient of restitution, right, இப்படிதான் அதோட definition வரும். The relative speed of separation divided by relative speed of approach. But careful observe பண்ணுங்க, we are not generally saying relative speed of separation by relative speed of approach. எந்த directionல? Along the normal line. So அந்த normal line இருக்கிற அந்த velocity components மட்டும் தான் நம்ம பார்க்கணும். ஓகேவா? So the relative speed of separation along the normal line. இப்போ பாருங்க, இந்த v2 அதோட normal component along the normal line minus v1 ஓட normal line component divided by அதுதான relative velocity of separation சொன்னா. Relative velocity of approach means what? u1 ஓட normal component minus u2 ஓட normal component. இங்க என்னன்னா வெறும் அந்த normal directionல இருக்கிற velocity component தான் நம்ம பார்க்கணும். So அது வெச்சு தான் we will define the coefficient of restitution. ஏன்னா remember one thing, coefficient of restitution ஓட main significance என்ன? It is going to tell us how the impulsive forces, how the impulsive forces are able to affect the velocities of the particles. அதனால என்னன்னா impulsive forces will be only along that normal line only, right? So we can only measure the impact of that impulsive forces along that normal line மட்டும்தான். So அதனால when you define the coefficient of restitution, right, இங்கேயும் அந்த மாதிரி தான். What is it? Velocity of separation after the collision divided by velocity of approach. But இங்க என்னன்னா வெறும் அந்த components of the velocities along the normal line மட்டும் தான் நம்ம எடுக்கணும். ஓகேவா? So this is the way in which is the general. இங்க என்ன தெரியுமா, to really solve this the oblique collision ஓட final velocity நமக்கு வேணும்னா it will be taking little bit more complex calculation. ஏன் தெரியுமா, இங்க பாருங்க, we will have the directions also coming in. இங்க பாருங்க, so if you are looking at the directions, right, see இந்த பக்கம் நீங்க ஒரு ஆல்பா வெச்சுக்கோங்க angle, இந்த பக்கம் பீட்டா. So v1 ஒரு வேரியபிள், அதுக்கப்புறம் v2 இங்க ஒரு வேரியபிள், ஆல்பா வேரியபிள் தானா, அந்த மாதிரி பீட்டா இஸ் ஆல்சோ வேரியபிள். ஸோ எங்கன்னா நிறைய வேரியபிள்ஸ் வரும். ஹெட் ஆன் கேஸ்ல என்ன, வெறும் 2 வேரியபிள்ஸ் மட்டும்தான், v1 and v2. பட் இங்க எப்படி பாருங்க, we will have more number of variables. அதனால என்ன, மோஸ்ட்லி ரைட், நமக்கு நீட் லெவல்ல we will have the simple level of questions. The oblique collision base பண்ணி we will have simple level of questions. Complete in the full getting the velocities with direction அதெல்லாம் நமக்கு இருக்காது. ஏன்னா because we will be having how many variables? 4 variables வரும். The velocity ஓட value, speed, அந்த மாதிரி what is the angle made by that velocity with the normal direction ஆகட்டும் or the tangential, whichever it is. So totally எத்தனை variables வரும்? 4 variables வரும். So the solving of this oblique collision, right, general நம்ம அப்படியே சால்வ் பண்ணோம்னா it is going to be little bit more, கொஞ்சம் டைம் எடுக்கும். And those kind of questions will not come in the neatல அந்த மாதிரி questions வராது. Either we will get some theoretical questions like இந்த மாதிரி theoretical based questions வரலாம், or we can have some simplified version of the problems. எந்த மாதிரி questions வரும்னு சொல்லிட்டு we look at it. So just look at this. This is a question that has come in the 2011 paper. A mass m moving horizontally along the x-axis with a velocity v. எப்படி பாருங்க, mass m is moving horizontally along the x-axis with a velocity v, means அதோட velocity என்னது, v into I cap ன்னு சொல்லலாமா, that is the velocity, and sticks to a mass 3m moving vertically upwards along the y-axis with a velocity 2v. So it is actually going and sticking and so that is also collision process only, right? It is sticking to a mass 3m which is going vertically upwards with a velocity 2v, means we can write it like 2v into j cap, and it is along the y-axis. The final velocity of the combination, this is oblique collision, the velocity of the m is along the x-axis, velocity of the 2m is along the y-axis. It is what oblique collision தானா, இது head on collision கிடையாது. Okay, but இதில் என்ன, they are sticking and moving. Finally both of them are sticking and moving, right? So total mass எவ்வளவு பாருங்க, what is the total mass finally? இது m plus 3m, what is it? 4m தானா? Remember, for any collision, right, we can apply the conservation of momentum. ஏன்னா whether it is an head on collision ஆகட்டும் or oblique, whatever be the collision, right, always collision என்னது, it's an internal phenomena, so we can use the conservation of momentum. Okay, so பாருங்க, m ஓட initial momentum என்ன, m into v into I cap, அதுதானா? அந்த மாதிரி 3m ஓட initial momentum என்ன, 3m into 2v into j cap. இதுதான் total momentum of the m and 3m. Finally let us say in the 4m total mass எவ்வளவு, 4m தானா? So 4m is moving with a velocity v dash னு வெச்சுக்கோங்க, அதுதான் நமக்கு வேணும். என்ன கேக்குறாங்க, they are asking what is the final velocity of the combination, the combination ஓட final velocity எவ்வளவுன்னு சொல்லிட்டு கேக்குறாங்க. So பாருங்க, if the 4m is going with a velocity v dash னு வெச்சுக்கோங்க, then what is the final momentum of the combination? 4m into v dash தானா? அவ்வளவுதான். We are able to get the answer. பாருங்க, what is it? m நம்ம cancel பண்ணா v into I cap plus இது என்னது, 3 2s are 6, 6v into j cap is equal to what, 4 into v dash. நமக்கு என்ன வேணும், v dash தானா? so அப்படியே அந்த 4 நம்ம left side எடுத்துட்டு வரலாம். so it will be what, v by 4 into I cap plus, which is what, 1 by 4 v I cap, 6 by 4 என்ன, 3 by 2 தானா? 3 by 2 v j cap. பாருங்க, so this is the final velocity of the combination, 1 by 4 v into I cap plus 3 by 2 v j cap. so இந்த மாதிரி questions தான் நமக்கு வரும். so completely solving that oblique collision அந்த மாதிரி questions வராது. ஏன்னா because that will be involving more number of variables. ஓகேவா? அந்த மாதிரி questions என்ன, because we will be having more number of variables. Okay ba? So look at obliquely அப்படிதானா, we'll get what, perfectly elastic oblique, அதுக்கப்புறம் inelastic oblique, அதுக்கப்புறம் perfectly inelastic oblique. Okay, so perfectly elastic oblique ன்னு சொன்னா what is the thing, the kinetic energy of the particles before the collision. ஏன்னா எல்லாத்துலயும் the conservation of momentum will be applicable. The conservation of momentum will be applicable. Okay ba? அதுக்கப்புறம் what else we'll have, conservation of kinetic energy, the kinetic energy of particles before the collision. அதனது half into m1 into u1 square. ஏன்னா நம்ம மெயினா கான்சென்ட்ரேட் பண்ணது the collision between two particles or two objects. So total initial kinetic energy of particles is equal to final kinetic energy of particles. Okay ba? So this will be there for the perfectly elastic oblique collision. Okay, so இங்க என்ன தெரியுமா, the idea of coefficient of restitution. so எவ்வளவு வரும், it will be equal to what, 1. but oblique collisionல வரும்போது what is the situation about the coefficient of restitution? it is only calculated by using the normal components of velocity. normal ன்னு சொன்னா what is it, when two objects are colliding, right, அங்க என்ன இருக்கும், there will be a contact surface. the direction normal to that is what you call as common normal. okay va? so அந்த direction இருக்கிற velocity components வெச்சு நம்ம இந்த e calculate பண்ணணும். so if you look at the e value, what is it going to be, it will be equal to 1. இதுலயும் அப்படிதான், for the perfectly elastic oblique collision இதுல என்ன வரும், e value will be equal to 1. but difference என்னன்னா, the e value will not be calculated by using the total velocities which we will not calculate. We will calculate by using only the normal components of that velocity. okay va? sometimes we can have questions which we will be able to solve just by using this equation. in the conservation of energy equation use பண்ணி we will be able to solve some questions. பாருங்க, this is a question that has come in 2015. on a frictionless surface, block mass capital M, அதோட ஸ்பீட் கொடுத்திருக்காங்க. what is the speed, speed v, collides elastically with another block mass capital M which is initially at rest. பாருங்க, so block m, another block m, ரெண்டு capital m தான் ஓகேவா. colliding, இதோட velocity என்ன v, but this is at rest ஓகேவா. after collision the first block moves at an angle theta to the initial direction, has a speed v by 3. so இதுதான initial direction. so at an angle theta, what is the speed v by 3? இங்க பாருங்க, here the directions வரும், அத நம்ம டிஸ்கஸ் பண்ணது. we will get what, the directions of the velocities. okay, so the initial direction order, it is making angle theta ஓகேவா. what is the speed v by 3? the second block speed after collision, what is it that we need to find? second block speed after collision. so இதெல்லாம் தெரியுமா, நான் சொன்ன மாதிரி கம்ப்ளீட்டா நம்ம சால்வ் பண்ணோம்னா we will have a little bit more time taking process. so usually நமக்கு என்ன வரும் நீட்ல, we will have the questions which we can solve by using these simple ideas. இங்க பாருங்க, this is what, இதனது oblique collision தானா, because they are moving in different directions. collision க்கு அப்புறம் they are moving in different directions, which means what, oblique collision தான். but என்ன தெரியுமா, it is a elastic oblique. elastic means what, we can apply another conservation of energy principle or conservation of energy ன்னு சொல்றதுக்கு பதிலா kinetic energy, means kinetic energy of particles before the collision. பாருங்க, before the collision only this one object மட்டும் தான் is moving. so what is the kinetic energy? half into m into v square is equal to, collision க்கு அப்புறம் the initial mass is going with how much speed, v by 3, means அதோட kinetic energy என்ன, half into m into v by 3 the square. okay, the second mass which is initially at rest, அதோட velocity v dash னு வெச்சுக்கோங்க, அத நம்ம find out பண்ணனும். so what we need to find, the second block oda speed after the collision. okay, அது v dash நம்ம எடுக்கலாம். okay, look at this. so what will be the kinetic energy of that, half into m into v dash square, அதுதானா. so we can cancel half m, ரெண்டு பக்கம் நம்ம அந்த half m cancel பண்ணலாம். cancel பண்ணா என்ன இருக்கும், v square is equal to v square by 9 plus v dash the square. ஓகேவா. so அந்த v square by 9 மட்டும் let us bring it to the left side. so v square minus v square by 9, what is it, 8 v square by 9, அதுதான் v dash square ஓட வேல்யூ, which means v dash எவ்வளவு, ரெண்டு பக்கம் நம்ம ரூட் எடுத்தா what is it, அவ்வளவுதானா. we got the answer. v dash தான நமக்கு வேணும். what is the v dash ஓட வேல்யூ பாருங்க, square root எடுத்தா we have to take the square root, right. square root எடுங்க, what is it, square root of 8 v square by 9 is equal to square root of v dash square, that is v dash only. ஓகேவா. so இந்த பக்கம் root எடுத்தா what is it, 2 root 2, root 8 எவ்வளவு, 2 root தானா, into v by 3, அதான் v dash ஓட வேல்யூ பாருங்க. so இந்த மாதிரி தான் நமக்கு क्वेश्चन வரும். completely solving that entire oblique அந்த மாதிரி क्वेश्चंस வராது. ஏன்னா because நான் சொன்ன மாதிரி will be having அங்க என்ன வரும், 4 variables வரும், speed values v1 v2, அதுக்கு அப்புறம் the angles made by the velocities with either the tangential direction or the normal direction. அதனால we will have more complication in solving those questions. இந்த மாதிரி questions வரலாம், like straightforward, right. இதுக்கு முன்னாடி நம்ம பார்த்ததுல we have used conservation of momentum, இதுல என்ன we are using conservation of energy. okay, so they will give us problems by giving us a lot of information. இங்க என்ன தெரியுமா, அந்த v dash தவிர everything is given to us. okay, so they will give us extra information so that we can just solve the question by using one equation. இது முன்னாடி ப்ராப்ளம்ல we are able to solve the question by using conservation of momentum principle. இங்க என்னது, we are able to solve the question by using the conservation of kinetic energy, because they are saying it is elastic collision, right. okay வா. so இந்த மாதிரி questions தான் நம்ம practice பண்ணணும். so அடுத்த கேஸ் என்ன, if you have inelastic collision in the oblique category, oblique category we are having inelastic collision ன்னு சொன்னா இங்க என்ன வரும், e வரும், coefficient of restitution. okay, so அதுல என்ன தெரியுமா, so in case of this inelastic oblique collision la the components of velocities along the tangential direction, okay va, சேஞ்ச் ஆகாது. பார்ட்டிகல் 1 ஆகட்டும் பார்ட்டிகல் 2 பார்ட்டிகல்ஸோட இது என்னது, this is the tangential, right? Tangential directionல the velocities of the components they will not change. Which direction they will change? Along the normal direction. And the impact of that impulsive force, right? That will be only along the common normal. So then this is a common normal. So impact of that collision forces and solala or the impulsive forces, right, will be along the common normal. Okay. So E will be what? The relative velocity of separation measured along the normal direction divided by the relative velocity of approach. In the direction la along the normal. So on the normal components மட்டும் தான் நம்ம எடுத்துட்டு we will be able to use this quotient of restitution. Okay, இங்க அப்படிதானா, what will be the range of this E value? It will be between 0 to 1. What will be the range of the E value? It will be between 0 to 1. Okay va? So பாருங்க what kind of questions possibly we can expect. Ball mass m hits the floor with a speed v0 making an angle of incidence alpha with the normal. So what is the angle it is making with the normal? Alpha. The coefficient of restitution E. What is the coefficient of restitution? E. Find the speed of the reflected ball. So நம்ம என்ன calculate பண்ணனும்? We should calculate what is the speed of the reflected ball. பாருங்க. So in the direction la vandhudu. It is making an angle alpha with the normal. It is making an angle alpha with the normal, right? இங்க பாருங்க, this is the normal. This is our contact surface or the tangential. Okay, it is coming at an angle alpha with the normal coming and hitting that surface. Okay va? So இங்க என்ன தெரியுமா, when you take the velocity into components, இங்க observe பண்ணுங்க, nothing is going to happen to the floor, right? Floor அப்படியே இருக்கும், only the ball is going to get bounced. Okay, so நீங்க அந்த ball ஓட velocities நம்ம resolve பண்ணா what is the components பாருங்க. இங்க இருக்கிற angle நம்ம alpha ன்னு சொன்னா what is this angle going to be? Alpha, vertically opposite angles. Okay, so பாருங்க, the component along the normal line v0 cos alpha, component along the tangential v0 sin alpha. Now we are going to number 7 point. What is it? The components of that velocities of particles along the tangential line அது அப்படியே இருக்கும். They will not be changing. They will not be changing. What will be changing? வெறும் the components along the normal line direction இருக்கிற components மட்டும் தான் சேஞ்ச் ஆகும். ஓகேவா? பாருங்க, the tangential அந்த ஒரு component value அப்படியே இருக்கும். That will be what? Unchanged. It remains unchanged. ஓகேவா? What will be changing? Only the component of that velocity along the normal line. இங்க பாருங்க, bouncing back ன்னு சொன்னா the component, so before it is coming and colliding, right, normal direction இருக்கிற component எப்படி இருக்கா? It is down. Collision component is bouncing back, right? So அது எப்படி வரும்? It will be vertically up. So அதோட வேல்யூ நம்ம v ன்னு சொல்லலாம். V is what? The component along the normal after collision க்கு அப்புறம். ஓகேவா? So இங்க பாருங்க, what is the definition of quotient of restitution? The velocity of separation after the collision. பாருங்க, collision க்கு அப்புறம் with what speed the ball is raising. We have to look at only the normal direction மட்டும் தான் நம்ம பார்க்கணும். In case of oblique, we have to look at what? Normal direction. So what is the relative velocity of separation in the normal direction? V dana, because the ground is as it is going up. What is the velocity component along the normal direction? V only, right? So that is the relative velocity of separation after the collision. What is the relative velocity of approach before the collision? So பாருங்க, relative velocity of approach ன்னு சொன்னா வெறும் அந்த normal direction இருக்கிற component தான் நம்ம பார்க்கணும். ஓகே, இங்க பாருங்க, what is the component of velocity? Surface அப்படியே இருக்கா, surface is not moving. So the component of velocity along the normal direction என்னது? v0 cos alpha. That is our relative velocity of approach. ஓகேவா? So E எப்படி வரும் E ஓட வேல்யூ the relative velocity of separation after the collision along the normal line divided by the relative velocity of approach before the collision. அதே அப்படிதான் we have to take only along the normal line. அந்த normal lineல தான் நம்ம எடுக்கணும். ஓகேவா? சோ இங்க பாருங்க, what is it? இதுல இருந்து we will be able to get the v value. so v எவ்வளவு வருது? E into v0 into cos alpha. அதுதான் v value. so v value வந்து நம்ம கிட்ட what is v value? E into v0 into cos alpha. நமக்கு என்ன வேணும்? we are supposed to find what is the speed of the reflected ball தானா? speed means what? it is having two components. one என்னது component along the tangential line, ரெண்டாவது component along the normal line. speed ன்னு சொன்னா magnitude தானா? what is the magnitude of the total velocity root of perpendicular components, right? v0 square sin square alpha plus e square v0 square cos square alpha. அவ்வளவுதான். so this is what speed of the reflected ball. இங்க வர கான்செப்ட் என்ன? where we will take the coefficient of restitution. so coefficient of restitution எங்க வரும்? it will be only coming in the case of the components of the velocities which we will take along the normal direction. okay va? so that is the important point about the coefficient of restitution in case of the oblique type. okay va? அவ்வளவுதான். so இதுல இருந்து we can take maybe and the v0 square common எடுத்துட்டு we can just take it out. okay, so v0 square வெளிய வந்தா it will be what? v0 தானா? v0 square நம்ம வெளிய எடுத்துட்டு வந்தா it will be what? v0. okay, அந்த மாதிரி நம்ம simplify பண்ணலாம். like that we can simplify and write the answer, but we can simplify based upon the options given. இங்க என்னன்னா we are not taking any options, right? we are just doing it like a normal question. so அப்படி if you want to know the simplification means என்ன பண்ணலாம்? இங்கல இருந்து நம்ம v0 square வெளிய எடுத்துட்டு வரலாம். it will become what? v0 into root of sin square alpha plus e square cos square alpha. இதுதான் speed ன்னு சொல்லலாம், or the magnitude of the velocity of the reflected ball. okay va? so அடுத்தது என்னன்னா the case of perfectly inelastic collision. what is the other word that we use for this? plastic collision in case of the oblique type. okay, so a lot of students will have some confusion here. ஏன்னா நம்ம perfectly inelastic or plastic ன்னு சொன்னா what is the general thinking that we'll have? collision க்கு அப்புறம் they will stick and move. அதானா? so head on நம்ம என்ன பார்த்திருக்கோம்? in case of head on, right, what is it that we saw? after collision the particles stick and move. அப்படிதானா? that is the result we got. but basic idea அது கிடையாது. basic idea என்ன? perfectly inelastic ன்னு சொன்னா what is the basic idea? the kinetic energy loss. ஏன்னா generally when we say inelastic அதுல என்ன நடக்கும்? kinetic energy will be lost. the kinetic energy loss is going to be maximum in one particular situation. ஒரு particular scenario ல kinetic energy loss will be maximum. அது என்னது? in case of the head on type of collision, when both of them move with a common velocity, right? stick and sonna, it is not like always they are physically stick ஆயிட்டு they are not moving. it is not like that. collision க்கு அப்புறம் they will be moving with a common velocity. அதுதான் concept. they stick and move and sonna what is it? they will move with a common velocity. அந்த ஒரு situation என்னன்னா the kinetic energy loss will be maximum. அதுதான் concept. okay va? and we have seen in that case E will be equal to what? 0. in that perfectly inelastic discussion that we had about the head on, adula E oda value enna varum? 0. okay va? that is what we have seen in the case of the head on. but inga vaanga, so we will discuss about the oblique category la. what about the perfectly inelastic or the plastic type of collision? inga enna theriyuma? first of all understand this. நம்ம என்ன சொல்லிருக்கோம்? if the objects are having velocities u1 and u2, நம்ம அதோட காம்பனன்ட்ஸ் எடுக்கலாம். ஸோ டான்ஜென்ஷியல் காம்பனன்ட், அதுக்கப்புறம் இது என்னது நார்மல் காம்பனன்ட். Tangential components will not change. Why? Because the collision forces or the impulsive forces, right, they will only create impact along the normal line. அதனால என்ன, the tangential components of the velocities will not change. Means the whatever the tangential components, right, அது அப்படியே இருக்கும். Whether it is a perfectly elastic oblique ஆகட்டும் or inelastic oblique ஆகட்டும் or perfectly inelastic oblique ஆகட்டும், so எல்லாத்துலயும் what is it, the components along the tangential will not change. ஏன்னா the impact force ஓட இது it is not going to be acting along the tangential line. அப்படி சொன்னா then think about it, what will be the maximum kinetic energy loss situation here? இங்க என்ன தெரியுமா, the maximum kinetic energy loss situation will be when same E is 0. E is 0 means what? So E means E here will be calculated only for the normal direction components of velocity. So E is 0 means the relative velocity of separation along the normal, total relative velocity of separation கிடையாது, வெறும் along the normal direction மட்டும். if you take the component பாருங்க, so collision க்கு அப்புறம் let's say இதோட velocity v1 வெச்சுக்கோங்க, இதோட velocity v2, we have to take v1 ஓட component along the normal, அந்த மாதிரி v2 component along the normal. The relative velocity of separation along the normal direction will be what? 0. ஓகேவா? means in the normal direction la whatever is the first object ஓட velocity, right, will be equal to the second object velocity. Okay, so paranga we will write these conclusion points, and this is an important area for the theoretical questions. So finally enna theriyuma, what we are going to conclude, what is it that we are going to conclude? Paranga, oblique perfectly inelastic, right, the particles collision ku appuram they need not move together, collision ku appuram they need not move together. Paranga, so what is the conclusion? Second conclusion, first conclusion namukku already irukka, what is it? Whatever is their original tangential velocity components அது அப்படியே இருக்கும், அது சேஞ்ச் ஆகாது. the components of velocities along the normal will be equal for both particles. ஏன்னா quotient of restitution is 0. அந்த ரெண்டு ஆப்ஜெக்ட்ஸோட டோட்டல் வெலாசிட்டிஸ் ஈக்குவல் கிடையாது. என்னது, the components of velocities along the normal direction will be equal, but along the tangential they may have different velocities. Tangential level they may have different velocities. So after collision they need not stick and move. எப்போ தெரியுமா, when they will stick and move, when their tangential components, ஏன்னா tangential components change ஆகிறது கிடையாது, they are as it is, right. If the u1 ஓட tangential component அந்த மாதிரி u2 ஓட tangential component அந்த ரெண்டு வேல்யூஸ் ஈக்குவல் வெச்சுக்கோங்க, then collision க்கு அப்புறம் they are going to be as it is, normal components ஈக்குவல் ஆகும், so they will start moving together. அப்பதான் நம்ம மூவிங் டுகெதர்னு சொல்ல முடியும். புரியுதா? so நம்ம அந்த ஹெட் ஆன்ல சிம்பிளா நம்ம சொல்லிருக்கோம், what is it, collision க்கு அப்புறம் they will stick and move. lot of people remember it like this only, perfectly inelastic and சொன்னா objects will stick and move and சொல்லிட்டு. but in case of oblique it need not be like that. okay, we are not saying it will not be, another we are saying it need not be like that. ஏன்னா collision க்கு அப்புறம் வெறும் the normal component of velocities will become equal for both the particles, but tangential components அதோட original values அப்படியே வரும். So when we can have the situation of moving together, எப்போ the case varum, when initially whatever the tangential components irukku theriyuma, if they are also equal for both the particles, enna tangential component of the velocities oda values change agadu. If they are also same, then we will see that collision ku appuram the particles will start moving together. Okay va? So this moving together in a perfectly inelastic collision, that will be only for the head-on category. Okay va? Oblique lenna எப்போ நடக்கும் அது? When it will happen, we need to have this condition. What is the condition? And the particles oda tangential component of velocity should be same. அது அந்த கண்டிஷன் இருந்ததா collision க்கு அப்புறம் they will start moving together. இல்லனா normal components may be same, but tangential components different இருந்தா என்ன ஆகும்? One will go faster. அந்த மாதிரி தானா? They will not go together. Okay, so this is a very important theoretical question that can be asked. But whether it is a head-on agato or the oblique, coefficient of restitution, right? E oda values will be, so elastic and sonna E is 1, angiyo padudha ingiyo padudha, but the thing is that the way we define E is different. Okay, inelastic case la E will be between 0 to 1, head-on la padudha, as well as in case of oblique also same. Perfectly inelastic, E is 0 in both the cases. Okay, but in the moving together condition will not be there for all the perfectly inelastic oblique collisions. ஒரு சில கேஸ்ல அது நடக்கும். எப்போ? when the particles oda tangential component of velocity is same, right? அப்போதான் அந்த particular condition வரும், moving together condition. Okay va? So this is a very important theoretical question, and this is a thing that lot of students will keep asking. Okay, paranga, what is this question? This is a question based on the perfectly inelastic. After perfectly inelastic collision between two identical balls moving with same speed in different directions, the speed of the combined mass becomes half the initial speed. And this is a symmetrical situation. Paranga, we are having what? See, we are having two masses. Okay va? They are moving with same speed. Okay, so let us say the speed of the value v vechkonga in different directions. Different directions means they will have some angle between them, so the angle theta nu vechikalam. Collision ku appuram what is happening? They are moving, the combined mass is moving with half the initial speed, means it is moving with how much speed? V by 2. Collision ku appuram it is moving with how much speed? V by 2. Okay, find the angle between the two objects before the collision. Theta da நம்ம calculate பண்ணனும். எது நம்ம calculate பண்ணனும்? We should find the theta value. Okay, so எப்படி, how do we calculate the theta? Because they are saying perfectly inelastic collision சொல்றாங்க, but we can straight away use what? Conservation of momentum use பண்ணலாமா? பாருங்க, what is the momentum here? For this mass it is mv, and மாதிரி for this mass it is what? mv. What is the angle between them? Theta. Okay, what is the resultant momentum? Vector dana, a square plus b square plus 2ab cos theta. That is what it is. The resultant momentum is what? Root of, it's like a vector resultant, root of a square plus b square plus 2ab cos theta. Inga parunga, what is the final momentum? 2m is going with a velocity v by 2. What is the momentum? 2m into v by 2. That is mv. Okay, so inga parunga, the resultant momentum, right? Initially whatever is the momentum of both the particles, that is equal to final momentum. Equate pannunga, what you will get? 2 times m square v square plus 2 times m square v square cos theta is equal to what? mv. Rendu pakka square panna, what is going to happen? The root will go off. So left hand side la 2 m square v square cos theta is equal to m square v square. Okay va? So idukku appuram nama step by step simplify panna avladha. Pananga, what is the answer for this question? So ரெண்டு பக்கம் நம்ம அந்த m square v square cancel பண்ணலாம். cancel பண்ணா என்ன வரும்? 2 plus 2 cos theta is equal to 1. அப்படியே அந்த 2 நம்ம ரைட் சைடு எடுத்துட்டு போலாம். It will become what? minus 2 ஆயிடும். 2 cos theta is equal to 1 minus 2, which is minus 1. Cos theta எவ்வளவு? minus half. Cos theta minus half means what is theta value? 120 தானா? Because cos 120 எவ்வளோ? minus half. That's the answer. அவங்க என்ன கேட்குறாங்க, the angle between the two bodies before the collision, அது என்னது? theta is equal to 120. அதுதான். What is the answer for this particular question? எவ்வளவு பாருங்க, theta is equal to 120. ஓகேவா? so அடுத்து என்ன, we'll go to the explosion part. explosion அப்படிதான், like if you look at any object, right, like you have a bigger object, it may be typically we look at the explosion in the case of bomb or some object like that. Okay, so this is only for the theoretical study. Even when we go to +2, again we'll have the phenomena of nuclear fission. Fission means a large nucleus, right, breaking down into smaller fragments. That is also the same case. Okay, so enga parunga, the explosion happens because of something that is inside whatever the internal mechanism, right, internal force or internal energy. Like typically in a bomb, right, there will be chemical energy stored. Okay, so once the chemical reaction happens, the trigger action, it will be creating some chemical reaction. So adulande we will see the energy being released, and the energy will create it will create kinetic energy for the particles produced, and the mother it might also produce some light energy, heat energy, sound energy. Okay, all these things will come from where? From the internal energy, whether it is the chemical energy. So in case of bomb, the chemical energy la varum. Okay, in case of nuclear fission, it comes from the nuclear energy. Okay, so idu patti we'll discuss about it when we go to the modern physics in +2. Okay, so what is the nuclear energy? Nuclear energy enna theriyuma, some mass will be converted into energy that we will solve by using the Einstein's mass energy equivalence principle, and the E is equal to mc² formula. Adilande we'll be able to find out what is the energy released when a mass m is converted into energy form. Okay va? So whatever it is, right, the explosion in the case of bomb or the nuclear fission, the phenomena is because of the internal the object kulla nadakara oru force or chemical reaction or the nuclear phenomena. Adilande the energy is being produced, and because of the energy we will see that particles will be moving away by gaining kinetic energy. Adilande sometimes we can see light produced, heat produced, sound produced, adella varum. Okay va? So this is about the case of the explosion. Okay, now because it is internal phenomena, right, we will be able to apply the conservation of momentum. Because whatever is happening, paranga, so let us say there is an object of mass m. Most of the cases it will be at rest. Most of the cases it will be at rest. Okay va? If it is undergoing explosion into different parts. Let us say it is breaking into m1, m2, m3, m4. Other respective velocities are v1 bar, and a velocity is a vector, v2 bar, v3 bar and v4 bar. Explosion process there is no external force acting, right? So initial momentum evla, if it is at rest means 0 dana. Final momentum will be what? m1 v1 bar plus m2 v2 bar plus m3 v3 bar plus m4 v4 bar. So whatever is the initial momentum will be equal to final momentum of all the particles. And the explosion in the எல்லா particles ஓட momentum நான் add பண்ணனும். But இதுல என்ன தெரியுமா, when you are adding நம்ம கேர்ஃபுல்லா இருக்கணும். ஏன்னா momentum என்னது, it's a vector quantity. அப்படி நம்ம values 1 plus 2 அந்த மாதிரி நம்ம பண்ணக்கூடாது. We have to consider the directions part. Directions ஓட சேர்த்து நம்ம எடுக்கணும். ஓகேவா? So that is the thing that we need to look at the conservation of momentum principle in case of explosion. Okay, ஏன்னா collisionலயும் அந்த மாதிரி தான் வரும், because it is the internal phenomena. Explosion அப்படிதான், it is an internal phenomena. Okay, so explosion of a bomb or explosion of any object or the nuclear fission, all of them will have the same relation. Okay, இங்க பாருங்க, if this is not at rest, initially it is having some velocity v ன்னு வெச்சுக்கோங்க. Initially that object, right, பெரிய object is having a velocity v. அப்ப என்ன தெரியுமா, what will be the initial momentum? 0 வராது, it will be what, m into v bar. அதுக்கு ஒரு வேல்யூ இருக்கும், அவ்வளவுதான். Whatever is the initial momentum, right, most of the cases என்ன இருக்கும், it will be at rest. Sometimes the object before the collision might be already moving. அப்ப நமக்கு என்ன ஒரு result, initial momentum will be what, whatever is the momentum of that body before the explosion முன்னாடி, that will be equal to final momentum. Final momentum ன்னு சொன்னா it will be momentum of all these parts that will come out from the explosion வந்து வர whatever the particles, right, அதோட total momentum நம்ம add பண்ணணும். ஓகேவா? So this is about the conservation of momentum in case of the explosion. Okay, இங்க என்ன தெரியுமா, generally the kinetic energy final value will be more than initial kinetic energy. பாருங்க, so if you take the case of object totally at rest, initial restல இருந்தா, what is the initial kinetic energy? 0 தானா? Explosion க்கு அப்புறம் they are all moving different directions, means each and every part is having kinetic energy. So final kinetic energy of the particles, நம்ம எல்லா kinetic energy add பண்ணா it will be more than the initial kinetic energy of the original object. So எங்கல இருந்து வருது, where is this energy coming from? This change in kinetic energy, right, will come from எங்கல இருந்து வரும், it will come from the internal energy. ஏன்னா whenever there is a bomb explosion, அதுக்குள்ள என்ன நடக்கும், there is a chemical reaction that is happening, அதுல இருந்து you will get the energy. Okay, most of the times என்னன்னா some part of the energy will be coming into kinetic energy of the particles, remaining energy it will go in the form of explosion ஆயிடுச்சு வெச்சுக்கோங்க, you will see lot of noise, right, it will go in the form of sound, it will go in the form of light. Like, you know, if a bomb is exploding in a place, means you will see huge light that is coming in, and also heat. Okay, some amount of energy will be converting into kinetic energy form, some energy will be going into the heat energy form, light energy form, sound energy form, and the madri. Okay va? So this is about the concept of explosion. So main enna theriyuma, we will get questions where we have to use this conservation of momentum, adu base panni da varum. Okay, sometimes they can also ask us like what is the increase in kinetic energy, அந்த மாதிரி கேட்கலாம். Increase in kinetic energy means what? ஏன்னா கண்டிப்பா இந்த எக்ஸ்ப்ளோஷன் கேஸ்ல என்ன நடக்கும், the final kinetic energy, எல்லா particles ஓட final kinetic energy நம்ம ஆட் பண்ணா that value will be higher than the initial kinetic energy. ஏன்னா maximum கேஸ்ல initial kinetic energy 0 தான் இருக்கும். Most of the cases என்னது, the object will be initially at rest. Okay, so final kinetic energy will be always more than the initial kinetic energy. So on the change in kinetic energy agala, or that increase in kinetic energy, right, they can sometimes ask us the value also. Okay, so we'll see what are the kind of questions that were asked. Paranga, this is the question that has come in 2003 la vandadu. A stationary particle explodes into two particles, m1 m2. Stationary and sonna, what is it? Rest. Okay, it is at rest. It is exploding into two parts. one is m1, other is m2, okay va, which move in opposite directions. They'll be moving in opposite directions. This is the point that we need to keep in mind. If an object, stationary object, it is exploding into two parts, stationary object is exploding into two parts. If the part 1 is moving in right side direction, then part 2 has to move in the left side direction. Part 1 moving in the right side means part 2 has to move exactly in the opposite direction. And look at it. Initial momentum evla, because that object is at rest, right? So initial momentum evla 0. Final momentum am sonna, because momentum is a vector. Final momentum means what? The right side, let us say I cap and ichkonga. Left side will be what? Minus I cap. So the final momentum also must be 0, right? So whatever the momentum of that particle 1, that should be cancelled by the momentum of the particle 2. Whatever the momentum of particle 1, what is the momentum of particle 1? m1 v1 into I cap. That should be cancelled by the momentum of second particle, means second particle momentum should be exactly in which direction? Minus I cap direction. So what is it? It will be what? m2 v2 minus I cap. So in the condition, what is the condition we'll have? Initial momentum 0 dana. So final momentum must be equal to initial momentum. So m1 v1 minus m2 v2 into I cap, that is equal to 0. Means m1 v1 minus m2 v2 should be 0, right? Which means m1 v1 should be equal to m2 v2. That is the relation between their velocity or the magnitudes or the speeds. They should be moving in opposite directions. Okay. What is the relation between their magnitudes of speeds or the magnitude of the momentum? What is it? m1 v1 value y should be equal to m2 v2, but directions they must be opposite. Okay va? So this is about the particles moving after collision, after explosion from a stationary object. For stationary object, if it is exploding into two parts, means both the parts must move in exactly opposite directions. Okay va? So in the question, what is the question? Stationary particle exploding into two parts, m1 m2, which move in opposite direction with velocities v1 and v2. நம்ம இங்க டிஸ்கஸ் பண்ண மாதிரி தான். They are moving in opposite directions. Okay va? கண்டிப்பா அப்படிதான் மூவ் ஆகணும். Then only the total final momentum can be equal to initial momentum. And initial momentum is 0 dana. So finally the momentum of one particle should be cancelled by the momentum of the other particle. Okay va? இதுல என்ன, the ratio of kinetic energies of the particles. எது நம்ம calculate பண்ணணும்? We should calculate the kinetic energies of the particles or ratio. K1 by K2 நம்ம calculate பண்ணணும். What is K1 by K2 means? Half m1 v1 square by half m2 v2 square. அதுதானா? Half of cancel ஆயிடும். பாருங்க, m1 v1 into v1 divide by denominator பாருங்க, m2 v2 into v2. ஏன் நம்ம இப்படி எழுதுறோம்? because we can cancel. already நம்ம கிட்ட ஒரு relation இருக்கு. what is it? m1 v1 is equal to m2 v2, right? so அப்படியே அந்த m1 v1 m2 v2 cancel ஆயிடும். so what is the ratio? v1 by v2 வந்தது. பட் ஆன்சர்ல பாருங்க v1 by v2 கிடையாது. நமக்கு என்ன வந்தது? k1 by k2 is equal to v1 by v2. பட் ஆப்ஷன் என்ன? v1 by v2 கிடையாது. then we have to think, can we write it in terms of mass ratio? பாருங்க, m1 v1 is equal to m2 v2 தானா? m1 v1 is equal to what? m2 v2. so அதுல இருந்து what we can get? v1 by v2. பாருங்க, v1 by v2, right? v1 by v2 will be what? m2 by m1. எங்கல இருந்து வரும்? so look at this relation, right? so what is so m1 v1 is equal to m2 v2. so அந்த v2 left side எடுத்துட்டு வாங்க. so v1 by v2 எவ்வளவு? m2 by m1. அவ்வளவுதான். so v1 by v2 நமக்கு வந்தது. what is the ratio of kinetic energy? v1 by v2 தானா? so v1 by v2 can be written as what? m2 by m1. Good, Aditi, Maithili, Sanju, Vikashini. I think you are able to give correct answer to the previous question. But inga paranga, what is the answer for this? M2 by M1 dana. Another question paranga. An explosion blows a rock into 3 parts. How parts are 3 parts are okay va? 2 parts go off at right angles to each other. These two are 1 kg. Other velocity 12. Adukapram 2 kg with a velocity 8. Okay. So paranga 1 kg is moving with a velocity 12 meter per second. Adukapram 2 kg is moving with a velocity 8 meter per second. They are moving in right angles to each other. Okay va? The third part flies off with a velocity 4 meter per second. Third part of the velocity they are giving us. What is the velocity? So M3 or the velocity anna? What is the velocity of the third part? 4 meter per second. Nama enna calculate pannum? The third part of the mass nama calculate. Okay. So we have to assume that the rock or initial state but rock and sonna what we'll assume? We'll assume that initially the rock is at rest. Assume means initial momentum is 0. Initial momentum of that the rock before the explosion is 0. Okay. So if the initial momentum is 0, final momentum also must be 0. So initial momentum is 0. So consideration of momentum, right? So final momentum also must be 0. Final momentum 0 means what? Already we are having information about momentum of 2 particles. This is the momentum P1. What is it? 1 into 12. That is 12 kg meter per second. This is the momentum P2. What is it? 2 into 8. That is 16 kg meter per second. Okay, wow. Then 12. This is what? 16. Third particle, other momentum is P3. Okay. The 3 values add panna, they should be adding up to 0 dana. P1, because the momentum is a vector quantity. Numbers add panna mudiyadu. We have to add them vectorially. So vectorially add panna, they should be adding up to 0. Initial momentum of the rock is 0. Okay. So when we add the momentum of the 3 pieces, they should add up to 0. The P1 vectorially add panna, so P1 plus P2 plus P3, they should be adding up to 0. If paranga vectors in the approach space, what is it? P1 plus P2. First P1 plus P2 resultant, what is it? It will be a vector which will be inclined at an angle between P1 and P2. Okay. That value paranga. What is the value? P1 plus P2 magnitude, because it is the resultant of P1 and P2 which are at right angles. So what is the resultant formula? Root of 12 square plus 16 square. What is the root of 12 square plus 16 square? 12 square means 144. 16 square means 256. Add panna 400. Root 400 means what? 20. Okay, wow. So P1 and P2 are the resultant namedta. It will be having a value of how much? 20 kg meter per second. That's P1 and P2 value. Now, P3 should have the same magnitude. P3 should have the same value as P1, P2 P3 add panna, we are getting 0. Means what? Whatever is the P1 and P2 resultant value, right? That is 20 kg meter per second. P3 should have the same magnitude, but direction should be exactly opposite. P1, P2 if you are adding P3 means totally they will be adding up to 0. So P1 and P2 resultant in 20 kg meter per second. That's the direction. P3 should have the same magnitude, but direction should be opposite. The third part of velocity speed value. Mass theriyada, adha nama calculate pannu. See, mass M3 and what is it? அதோட மாஸ் இன்டூ ஸ்பீட் which is 4 meter per second. அதுதான் மொமெண்டம். magnitude of p3 should be equal to what? p1 and p2 ஓட resultant magnitude which is what? 20 kg meter per second. அவ்வளவுதான், meter per second cancel ஆயிடும். 4 1s are 4 5s are. so m3 எவ்வளவு? 5 kg. கரெக்டா பாருங்க எப்படி இந்த ப்ராப்ளம் அப்ரோச் பண்ணோம்னு சொல்லிட்டு. நம்ம தெரியும் இனிஷியல் மொமெண்டம் 0, ராக்னா we are assuming to be at rest. so finally அந்த 3 parts ஓட மொமெண்டம் நம்ம ஆட் பண்ணா it should be adding up to 0 தானா? ஆல்ரெடி 2 pieces ஓட மொமெண்டம் நமக்கு தெரியும். so அதோட ரிசல்ட் நம்ம எடுத்தா the resultant is what? going to be exactly equal in terms of value with p3. direction is opposite. அப்போதானே நம்ம 3 ஆட் பண்ணா 0 ஆயிடும். okay, so அதுல இருந்து we are able to equate the magnitudes. third part ஓட mass m3 வெச்சுக்கோங்க. mass into அதோட velocity கொடுத்திருக்காங்க. velocity is equal to what? the momentum magnitude which is 20 kg meter per second. okay வா? so அதுல இருந்து we are able to get what is the missing value? m3. அடுத்த क्वेश्चन பாருங்க. this is another question 2014 ல வந்தது. a body mass 4m is lying in the xy plane at rest. means rest and சொன்ன உடனே this is the point we should take. initial momentum எவ்வளவு? 0. நான் சொன்ன மாதிரி maximum case எல்லாம் தெரியுமா? we have initial momentum 0 only. but ஒரு சில situations என்னன்னா they will be giving us the body initially moving also. okay, it suddenly explodes into 3 pieces. okay va? 2 pieces each mass m move perpendicular to each other with equal speed v. okay va? பாருங்க initial நம்ம கிட்ட என்ன இருக்கா? 4m இருக்கா. 2 pieces are moving collision explosion க்கு அப்புறம் they are moving perpendicular to each other with speed v. okay, third piece ஓட மாஸ் எவ்வளவு வரும் பாருங்க. ஏன்னா this is m, this is m. so third piece எவ்வளவு? 2m தானா? third piece எவ்வளவு? 2m. okay, இப்போ கேர்ஃபுல்லி பாருங்க. இங்க அப்படிதான். so இது நம்ம p1 வெச்சுக்கலாம், இது p2, this is what? p3. almost same type of question. but இங்க என்னன்னா they are asking something different. இங்க பாருங்க, the total kinetic energy generated due to explosion. இங்க கேக்குறாங்க they are asking what is the total kinetic energy generated due to explosion. the explosion நால what is the kinetic energy generated. இங்க பாருங்க, what is the kinetic energy generated means particle 1 ஓட kinetic energy, அந்த மாதிரி particle 2 ஓட kinetic energy, particle 3 ஓட kinetic energy. அப்படிதானா? so particle 1 kinetic energy என்ன? half into m into v square. particle 2 kinetic energy எவ்வளவு? அந்த மாதிரி half into m into v square. particle 3 half into mass நமக்கு தெரியும் 2m, but v தான் நமக்கு தெரியாது, அதோட velocity நமக்கு தெரியாது. okay, so that is why we are keeping it as what? v dash னு வெச்சுக்கலாம். okay, so இப்போ நம்ம என்ன பண்ணோம்? we should find what is the v dash. v dash value நமக்கு தெரிஞ்சா வெச்சுக்கோங்க, then we will be able to answer the question. we can answer what is the total kinetic energy generated due to the explosion. okay, எப்படி இதை நம்ம calculate பண்ணோம்? same இதுக்கு முன்னாடி நம்ம எடுத்த மாதிரி தான் approach. p1 p2 அதோட ரிசல்ட் நம்ம எடுத்து வெச்சுக்கோங்க. what is it? both are at right angles, right? so root of mv square plus mv square, அதாவது root 2 into mv. அதுதான் resultant of p1 and p2. இங்க பாருங்க, when total final momentum should be 0, right? ஏன்னா because conservation of momentum principle தானா? final momentum should be 0 means p3 ஓட value, right, should be numerically same as p1 and p2 ஓட resultant. ஏன்னா நம்ம p1 plus p2 plus p3 இது நம்ம ஆட் பண்ணா they should be adding up to 0 தானா? which means what? p1 and p2 ஓட resultant, say for example இங்க என்ன வருது? root 2 mv வருது. p3 should have the same magnitude but direction is exactly opposite இருக்கணும். direction should be exactly opposite. okay வா? so இப்போ பாருங்க, what is the momentum of third mass? 2m into v dash தானா? 2m into v dash. okay, so இங்க பாருங்க m அப்படியே கேன்சல் ஆயிடும். so root 2v by 2 அதுதான் v dash. What is the v dash value? Root 2 v by 2. அவ்வளவுதான். That's it, right? So what is they asking? The kinetic energy generated due to the explosion. Explosion ala what is the kinetic energy generated? அப்படியே அந்த formula கிடையாது, இந்த expressionல we have to substitute the value of v dash. v dash எடுத்து அப்படியே substitute பண்ணுங்க. பாருங்க, this is what half mv square plus half mv square, that is mv square plus 2 cancel ஆயிடும், m into v dash square. v dash means what? Root 2 v by 2 the square. பாருங்க, what is it? mv square plus m into root நம்ம ஸ்கொயர் பண்ண என்ன வரும்? 2 வரும். So பாருங்க, what is it? mv square plus half mv square. இது என்னது? பாருங்க, what is the answer? 3 by 2 mv square. Okay, so this is the kinetic energy generated due to the explosion. Okay va? So good Aditya and Maithili, you are able to give answer for the previous question also. So the last question paranga. So that is it, guys. Idoda we have completed the work energy and power chapter. I think we have taken quite a number of classes and tried to cover this as much comprehensively as possible. You can go and practice some test based on this chapter, and you can even try to work out past year questions in work out panla, and you can even try and solve some more additional exercise questions. And next class we will start with the system of particles and rigid body motion. Okay, we'll see in the next class.